Okay, welcome to the next video where we are examining some human dimensions in the poles. In fact, I'll go ahead and add a note here for myself. Human poles, and this is going to be part 2 for us. And we've been looking at metal concentrations in Inuit diet and food. And so for our exercise here today, we're going to do a different kind of plot that requires a new package to be installed. And so if you're using RStudio here, you can come right up to Tools, go to Install Packages, go ahead and type one called Plotrix, and make sure Install Dependencies is installed, and go ahead and install it. There it is. And so the first line of our code is going to be to require Plotrix, and we can run that. Okay. So, similar to before, we're going to load our table 1 here from our Chan et al. Paper, which is the metal concentrations in Inuit food. So these are trace metal concentrations in the Inuit food coming from all across the food web, from ring seals down to blackberries, mussels, Arctic char, and we're going to look at that table a bit more closely. So just like last time, we're going to make our object called metal concentration, and we're going to read.csv. Again, where is this coming from? It's local on my computer. You should have downloaded it, so you're going to need to put your own path in here. So this is very similar to the last video. Go ahead and run this. There it is, and we can go over here to our environment, take a look at the metal concentrations. Here they are. There's our ringed seal, the different meat source, all the way down to bearded seal, narwhal, things of that nature. So if we're going to look at how maybe these metal concentrations are related trophically, that means according to the food web, we're going to want to pick maybe one kind of part of the animal, in this case maybe the meat, so I think we have that for each organism here, and go ahead and subset those things out. So we can see that the ring seal meat here is row 1, and the ring seal pup meat is row 11, and bearded seal meat is 13. And so if we go through this, if we just look at the raw meat, we can create an index. So it's just called our meat ind. It's going to be a concatenated vector of 1, 11, 13, 18, 26, 29, 37, 41, 52, 58, 60, and 61. So this is going to actually, maybe we should just call this our food index that we're going to be looking at. So our food index, these are the foods or the parts that we're going to be pulling out from. We're going to look at ring seal meat, and then our next one is going to be the 11th row, 13th, 18th, 26th, all the way down. And we're going to be looking all the way down, even down here to blackberries, which don't have meat. So we're just going to take that value. So that's going to be our food index. And then, so we're going to make another object here called trophic merc. And we're just going to take the metal concentration by the food our food index. And we'll go ahead and look at that now. Oh, conch. Hey. All right, so if we take a look at here's our trophic mercury now, we can take a look at that value. So here's what we chose. Here's ring seal, meat, ring seal, pup, bearded seer, narwhal, beluga, all the different meats, and then we've got mussels, kelp, and blackberries. All right, okay. So let's go ahead and sort that. I'm going to order that. Let's create a sort index. And we've done something similar to this before. We're just going to use the function order. Trophic merc. We're going to order it by the mercury concentration. So all this is doing is creating an index of the order that our trophic merc should be in. So we're just going to rewrite merc. It's going to be trophic merc index by the sort index. And this should just put it in order. So now when we take a look at trophic merc, there it is. We've sorted it by mercury concentration from blackberries, Arctic char, mussels, caribou, kelp, all the way up to beluga. Okay, so what we've done in the past is we've just done a bar plot. So if we do a bar plot of trophic merc, mercury, and we do names.arg equals trophic merc food source, we get, again, we have lots of low values and then giant values out here. So one thing that's helpful when you run into this problem like this is it's hard to compare what's going on down in these low levels because this one bar seems to be dominating everything. So we're going to be using a different type of plot. We're going to be using one called a gap bar plot. And what a gap bar plot does is it allows you to break this y-axis here so that you can actually see what's going on down here. So let me show you how this works. So gap bar plot, this is coming from Plotrix. Again, we're going to do the trophic mercury. Okay. Let's just show you what this looks like. Oh, gap must be specified. Yeah, sorry about that. So our gap in our data, the gap where we're going to break it is somewhere between, so this is 100, so we're going to break it between 100 and 700. And what this is that's just saying where the gap's going to be on the y-axis. There, okay, so now you can see that we've got all these values down here. They're not named yet, but you can see we've got this break in here so that we've made the 12th category not so big. Not so big. So what can we do here? Well, let's go ahead and mess with the color. Let's see, we get all these different colors in here. We really don't want, let's see, let's just do color. It's going to be a vector. We're going to repeat blue. Times equals 15. Yeah, that'll work. Actually, I think we only need 12. Oh, you know what? I'm going to come back up here to my food index. I don't know that we included everything. Yeah, we didn't include the greens, so I'm going to come back up here. 60, 61, 62, and 63 to get our greens in there. So I'm just going to run all this code here again. You'll see that we're just adding a few more categories. Okay, there we go. So we have a lot to do on this plot before we get what we want. So we notice our y ticks here, they're just 0 to 800, so there's an argument here called y ticks. Let's just make this a sequence from 0 to 800 by equals 20. Let's see what happens when we do that. Okay, so now we're getting there. So see, we go from like 0 to 100 here, and then 720 all the way up there. 800, we can even make this a little taller so you can see how that spreads out. That's nice. Okay, what else do we want to do to this one? Let's take the x-axis, take that out, and let's take our y-lab out, our y-label. I'm sorry, our x-label needs to be taken out. So let's run this and see what we get. Okay, we're going to add an axis, and now that's at a y-lab. Y-lab in this case is going to be mercury concentrations, micrograms per 100 grams. Just put a break in here in Inuit food items. Okay. Looks like we have a margin problem, so let's go ahead and fix that. So par mar, we'll see. Let's see, we're going to need a big margin on bottom, so let's do 14, 5, 2, 2. Remember, that's bottom, left, top, and right. Okay, good. Good, good. Okay, so now we just need to add an axis. We want to add axis on side 1, but if we just run this, it just puts that old axis back on, so that's not what we want. So we want it at 1 through 15. Let's go ahead and add that axis on. Oops. Equals 1 to 15. Okay, we're getting there. And now we can add labels on this. So what should the labels be? Well, the labels are going to be the species and the food source together. So what we can do is let's just take a look at this, at the trophic merc species. So that's those. And what about the trophic merc food source? Those are those. Well, we can actually paste those together. So let's paste trophic species and trophic merc food source. Yeah, those look like good labels now. Okay, we got 14 of them. Why do we only have 14 of them? Yeah, okay, I guess we only have 14. Make sure I have this right, because in my notes I have 15. So how many values do we have here? We're missing one, 57. What do we have in here that's 57? Oh, Sculpin. Yeah, okay, we wanted 56 and 57, so that's easy to fix. We just come right back up. This is the beauty of the code. We just go back up to our food index and run everything again, and it doesn't break. Okay, and we have our 15 categories there, and now we can run this code. Yeah, there's our 15 categories, from blackberries, Arctic char, greens, mussels, caribou, kelp, walrus, all those things. And those can be our labels now. Equals this command. Okay, let's run this. Okay, and oh, we got to use our LAS equals 3 to rotate them. Yep, and they're a little far off, so let's try this. Okay, there we go. All right, so now we've got mercury concentrations, microgram per 100 grams in Inuit food items. We've got blackberries on one end and beluga on the other end. We've used this broken bar plot so that we can see what all these other ones are in here. And you can see that we've got a bunch of marine mammals and fish on this side and none of those on this side. So that should tell you something about the trophic function up there in the Arctic. Okay, always remember to save your code. Go ahead and save this. All right, and thanks for watching.